Hi guys, welcome to my channel. In this video, let me explain the CLR parser. It is also known as Canonical LR parser, which is an important type of the parser used in the compiler design. A parser is responsible for checking whether the input program follows the syntax rules of the programming language. CLR parser is a bottom-up parser that uses the LR1 items to analyze the input and generate the parsing table. Let's go with the slides and let's understand in detail. Introduction to parsing. The parsing is a second phase of the compiler after lexical analysis. The main purpose of the parsing is to check the grammatical structure of the program, identify the syntax error, and generates a parse tree that represents the structure of the program. There are the two major types of parser. Top-down parser, which starts from the start symbol and tries to generate the input string. Bottom-up parsers starts from the input string and reduces it to the start symbol. CLR parser belongs to the bottom-up parsing category. The next slide is LR parser. The LR parsers are one of the most powerful bottom-up parsing techniques. The meaning of LR is L stands for left to right scanning. The parser reads the input symbol from left to right. R is the rightmost derivation in the reverse order. The parser constructs the rightmost derivation of the grammar in reverse order. There are the three main types of LR parsers. First one is SLR, simple LR parser, which is nothing but a simplest and less powerful. CLR, nothing but the canonical LR parser, which is most powerful but requires the more memory. LALR, look ahead LR parser, is the combination of the power and efficiency. I hope you guys understood. Let's move to the next slide. What is CLR parser? CLR stands for Canonical LR parser. It uses the LR1 items, where the number 1 represents the one look ahead symbol. The look ahead symbol helps the parser to decide whether it should shift an input symbol, reduce using a grammar rule, or accepts the input. CLR parser, some of the main components: LR1 items, closure function, GOTO function. There are the two important tables. It is nothing but action table and GOTO table. Action table decides the operation of the operation to perform. GOTO table decides or determines the next state after a detection. CLR parser can recognize the more grammars compared to SLR and LALR. Let's move on to the next slide. That is LR1 item. An LR1 item represents the current position of the parser during parsing. The general form is the production plus dot position plus look ahead. The general form is A produces alpha dot beta comma A. A is the grammar production. Dot is the current parser position. A is the look ahead symbol. Example, you can see here, S produces dot CC comma dollar. The dot before CC means the parser expects C symbol next, and dollar indicates the end of the input. I hope you guys understood. Let's move on to the next slide. Working principle of CLR parser. CLR parser works using the three main components. First one, input buffer, which stores the input string that needs to be checked. Second one is stack, which stores the states and grammar symbol during parsing. Third one is parsing table, which contains the action and go-to information. The parser checks the current states and input symbol, then performs the one of the action. Shift, reduce, accept, error. I hope you guys understood. Let's move on to the next slide, that is construction of CLR parsing table. To construct a CLR parsing table, we follows the 4 steps. The first step is augment the grammar. We add the new start symbol. For example, this is the grammar. S produces CC, C produces CC, C produces D. Where after we are applying the augment, it will be like S prime produces yes. This helps the parser to identify successful completion. Step 2. Generate the LR1 items. Step 3. Find the closure and go to. Step 4. Construct the action and go to tables. These are the 4 steps that are used to construct the parsing table. I hope you guys understood. Let's move on to the next slide. Closure operation. The closure operation is used to find all the possible LR1 items in the state. If the dot is before a non-terminal, we add the production of that non-terminals. For example, if we have A produces alpha dot B beta comma A. Since the dot is before B, we add all the production of the B. The closure helps in creating the complete status of the LR1 automation. I hope you guys understood. Let's move on to the next slide. GOTO function. The GOTO function determines the transition from one state to another. It shows what happens when the parser reads the grammar symbol. This is the formula. Go to I comma x equals j, where I is the current state, x is the grammar symbol, j is the new state. The collection of these states forms the LR1 automation. I hope you guys understood. Let's move on to the next slide, that is CLR parsing table. The CLR parsing table contains the 2 sessions. The first one is action table, another one is go to table. The action table tells the parser what action to perform. The possible actions are like shift, reduce, accept, error. Shift is nothing but we know which moves the input symbol to stack. Reduce, which applies the grammar production. Accepts, input is valid. Error, input is invalid and invalid syntax. Here in the table you can see ID is the shift, plus will do the reduce operation, dollar will accept it. Go to table. It provides the next state after reducing the production. It shows the transition between the states. I hope you got the clear idea. Let's move on to the next slide. Shift reduce operation. CLR parser performs the parsing using the shift reduce operations. Shift. The parser moves an input symbol into the stack. For example, action 0, comma ID equals S5 means shift the input ID and moves to the state file. Reduce. The parser replaces the sequence of the symbol with the non-terminal using a grammar rule. For example, C produces D. Accept. When the start production is completed, the parsing is successful. I hope you guys understood. Let's move on to the next slide. Example grammar. This is the grammar. S produces CC, C produces CC, C produces D. Input is CC, DD, dollar. The parser reads the input and performs the several shift and reduce the operations. Initially, it shifts the symbols into the stack. When it finds the valid production, it reduces the symbols. Finally, when the start symbol is obtained, it performs the accept operation. I hope you guys understood. Let's move on to the next slide. Advantages of CLR parser. It can handle the large number of grammars. It is more powerful than SLR parsers. It uses the look ahead information to reduce the conflicts. It detects the error at an early stage. I hope you guys understood. Disadvantages of CLR parser. Although CLR is powerful, it has some limitations. It creates a very large parsing table. It requires more memory. Constructing LR1 items is complex. Manual implementation is difficult. Because of this, LA-LR parser are commonly preferred in practical compiler tools. I hope you guys understood. Let's see the comparison of LR parsers. The main difference are, you can see in the table, SLR, CLR, LALR. SLR, the item types are like LR0. CLR, the item types are like LR1. LALR, the item types are LR1 merged. Look ahead will be for SLR follow, CLR 1 symbol, LALR 1 symbol. For the power, SLR will be less, that is low. CLR, it is highest. LALR is medium. Table sizes. SLR takes the small size. CLR takes the large size. LALR takes the moderate. I hope you guys understood. Let's move on to the next slide. Conclusion. To conclude, CLR parser is a powerful bottom-up parser used in a compiler design. It uses the LR1 items, closure and GOTO functions to construct the parsing table. Although it requires the more memory, complex construction, it provides a better parsing capabilities and fewer conflicts compared to other LR parsers. It is widely used as a foundation for automatic parser generators. I hope you guys understood. If you have any doubts, please raise your doubts in the comment box so that I can respond. Thank you. Please do subscribe to my channel. Thank you.